Friend, today we are going to discuss about how we find a particular integral of a linear difference equation with constant coefficient. So as we know that what is the general form of a linear difference equation with constant coefficient? F of e yx equal phi x. In a previous lecture, we discussed phi x equal a to power x, then how we find the particular integral. But here we are going to discuss if phi x equal polynomial of x, then how we find a particular integral. So to find out a particular integral, here just we write a particular integral equal phi x upon f of e, and then we write we replace e by the forward difference operator using the relation between shift and forward difference operator. So this one equal phi x upon f of 1 plus delta, because we know that what is the relation between forward and shift operator? Del equal e minus 1, then e equal 1 plus delta. Then we expand this one, we write this one f of 1 plus delta inverse phi x. So here we expand this term, expand this term, expand f of 1 plus delta inverse in ascending power of x, ascending power of delta means a forward difference operator. And why we expand in ascending power of a delta? This one is always a question arise in our minds, why we expand in ascending power of a delta. Then answer is delta is treated as a differentiation, means a forward difference operator is treated as a differentiation if any polynomial means is written in form of a factorial notation. So expand f of 1 plus delta whole inverse in ascending power of delta, and express phi x means a polynomial of phi x in factorial notation. So what is the benefit of this one? To express the phi x in a factorial notation. Once we express the phi x means a polynomial of x in a factorial notation, then when we operate the forward difference operator means a del, then we operate like a differentiation, and 1 upon delta work as a integration. So it's become easy for us to find out the value of delta of any polynomial, or 1 upon delta of any polynomial, once we write the polynomial in a factorial notation. So what is the summary of this one? This type of integral means how we find a particular integral. If phi x is a polynomial of x, just we write e in term of a forward difference operator and expand the f of 1 plus delta whole inverse in ascending power of deltas and express phi x in a factorial notation, then operate the polynomial over a function of 1 plus delta inverse, then be able to find out a particular integral. Now let us take one example how we find the based on this type of a particular integral. example 1, solve yx plus 2 minus 4yx equal x square. So how we find the solution? Just here we write the solution. Then how we find the solution? First we write the given difference equation in terms of a set operator. Then yx plus 2 minus 4yx equal x square. We write in a general form. Then e square yx minus 4yx equal x square. So here after simplification of this expression, this becomes e square minus 4 yx equal x square. So if we compare with the standard form, what is the standard form? Means a general form, f of e yx equal x square. So what is the complementary function? If we write a complementary function here, complementary function, because by putting f of e equal to 0, c1, by putting how we find a complementary function? Here just we erase out once this one. So how we find a complementary function? Solution become what? Solution of this difference equation is a yx equal complementary function plus particular integral. So first we find a complementary function. What is the complementary function? So to find out a complementary function, first we find a complementary function, then particular integral. To find out a complementary function, first we write a homogeneous equation of corresponding homogeneous equation of this equation, this non-homogeneous equation. What is a corresponding homogeneous equation? E square minus 4 yx equal 0. So after putting f of e equal to 0, this implies that e square minus 4 equal to 0. What is the value for e? E equal 2 comma minus 2. So what is the complementary function? Complementary function become c1 to the power x plus c2 minus to the power x. So now if we try to find out a particular integral, so what is the particular integral in this case? Particular integral become x square upon e square minus 4, and we compare with the standard form or general form. This one is a phi x upon f of e. So what is the procedure? Procedure is first we write f of e in terms of a forward difference operator and write phi x in factorial notation. So we try to write phi x in a factorial notation. Phi x equal x square. What is the factorial notation? If we write this term means x2 equal what? xx minus 1. And what is the x1? 1 equal x. So if we try to write x square, then x square can be written as what? X square can be written as, in terms of factorial notation, x2 minus the x2 become x square minus x, plus x. So this one is in term of a factorial notation. This one is a equivalent factorial notation of a x square. So phi x can be written as, here we write phi x in factorial notation, then phi x become x in square versus 2 plus x in a square versus 1. Now we express f of e in a term of a forward difference operator. So this one is a e square minus 4. Just we put the value of e in term of a forward difference operator. What is the value of e? Equal 1 plus delta. So this become 1 plus delta whole square minus 4. After simplification, what we get? We get delta square plus 2 delta minus 3. What is our aim? Our aim is to write the f of e in term of a 1 plus delta. So f of e equal, if we take outside minus 3, so this become minus 3 outside, then inside what will happen? This become 1 minus del square plus 2 delta divided by 3. So this one is in term of a delta. Now particular integral if we denote this one equation number 0, 1. Now equation 1 become what? Particular integral become x square in a factorial notation. This become x2 plus x1 and in a denominator, what is the value? Value become minus 3 and inside the bracket 1 minus del square plus 2 delta divided by 2 and this one inside the bracket. Now if we simplify this one, if a denominator goes in a numerator, then this become minus 1 upon 3 outside, and here this become 1 minus inside the bracket del square plus 2 delta upon, I think this one is not a 2, this one is a 3, because here we take minus 3 outside. So this one is a what? This one is a 3 inverse. So, and here in a factorial notation, this one become x factorial notation 2 minus plus x factorial notation 1. So now if we expand this term 1 minus delta square plus 2 delta upon 3, then and after some simplification, this become what? This become minus 1 upon 3. So this become minus 1 upon 3 outside, minus 1 upon 3, and inside what will happen? Inside this become 1 plus twice delta 2 delta upon 3 plus 7 delta square upon 9, and so on up to what? Up to x factorial notation 2 plus x factorial notation 1. So now we operate the here factorial notation over forward difference operator. There is no need to write other term because here factorial notation, in a factorial notation, highest superscript is a 2. So if we differentiate this one 2 times, then this become what? This become constant, and third time this become 0. So there is no need to write a del cube, del to power 4, del to power 6 like this one. Now if we operate this factorial polynomial of a factorial notation form of a polynomial over delta, then this become minus 1 upon 3 minus 1 upon 3 1 upon 3. First term remains unchanged, means x factorial notation 2 plus x factorial notation 1. Then 2 by 3, if we operate the delta over x factorial notation 2, then this become, this one is a work as a differentiation. Unless we not write the given polynomial in a factorial notation, we cannot directly differentiate or integrate any polynomial as if there is a del, then differentiation, then del is treated as a differentiation if we write in a factorial notations. Once again I repeat this statement. Why we write in a term of a factorial notation? Once we write any polynomial in term of factorial notation, then del means a forward difference is treated as a differentiation, and 1 upon del is treated as a integration. So 2 by 3 of a del here inside the bracket x 2 plus x1 1 bracket close plus 7 by 9 and inside the bracket x factorial notation 2 plus x factorial notation 1 bracket close. Now we simplify in the next phase. So what is the del of x2? This becomes 2x factorial notation 1, and what is the differentiation of x factorial notation 1? This one is a 1. So once we write again this expression in the next phase, then we try to find out the value of a differentiation. So what is the expression? Expression is our particular integral from here. This one is expression 7 by 9. This one is delta square. Sorry, this one is a delta square. So now in the next phase, particular integral become minus 1 upon 3 inside the bracket. First term with the x factorial notation 2 plus x factorial notation 1. Second term plus 2 by 3, that's 2 by 3 delta. Here inside this become x factorial notation 2 plus x factorial notation 1 plus 7 by 9 del square inside x factorial notation 2 plus x factorial notation 1. So if we close the bracket, now if we simplify this one, minus 1 by 3, there is no any change in the first term. This one is x factorial notation 2 plus x factorial notation 1 plus 2 by 3. If we operate the del over this expression, then this one is treated as a differentiation. So 2x factorial notation 1, and what is the differentiation of x factorial notation? X to power 1, this become 1, and second term becomes 7 by 9 second order differentiation of x square, first order become 2x, second become 2, and the differentiation of x to power 1, 2 time differentiation become 0. So this one is a after operating the delta over a factorial notation. Now we write the factorial notation in term of a original polynomial. So minus 1 by 3, here we write a x factorial notation 2 as x minus 1 and x1 with the x plus 2 by 3 inside 2 x plus 1 plus 14 by 9. So this one is a expression. Now after simplification of this expression, this become minus 1 by 3 inside this bracket, this become x square plus 4x by 3 plus 20 by 9. So this one is a particular integral. So what is the solution? Solution yx equal complementary function plus particular integral. So as previously we calculated the particular complementary function. What is the complementary function? C1 to the power x plus C2 minus 2 to the power x. So what is the solution? Solution become C1 general solution means yx equal C1 to the power x plus C2 minus 2 to the power x, and particular integral with the here not a plus, here we write a minus 1 by 3 inside the bracket x square here we write x square plus 4x by 3 plus 20 by 9. So this one is a required result. This one is a required result. So this one is a required result. Integral. Thank you for watching my videos.